Hello and welcome to Data Engineering with Subhadip. Today, we embark on an exciting journey to explore designing multi-cloud data architectures. We will learn how to build robust and scalable data solutions across various cloud providers. So what exactly is a multi-cloud data architecture? It is a strategy where an organization utilizes services from multiple public cloud providers, like AWS, GCP, and Azure for different aspects of their data infrastructure. This goes beyond simple disaster recovery, focusing on strategically placing workloads to leverage each cloud's strengths. It can also include hybrid cloud scenarios, integrating on-premise systems with multiple cloud environments to achieve resilience, optimal performance, and cost efficiency. So, why choose a multi-cloud approach? Firstly, it helps avoid vendor lock-in, giving you more flexibility. Secondly, it significantly enhances resilience and disaster recovery by distributing your workloads. You can also achieve better cost optimization by leveraging competitive pricing across different providers. Multi-cloud allows you to use best-of-breed services, picking the most suitable tools from each cloud. Finally, it helps with geographic presence, ensuring data locality for compliance and improved performance. Let's look at the core architectural components in any data pipeline, which are amplified in a multi-cloud setup. First, data ingestion involves collecting data, whether streaming or batch, into cloud storage. Next, data storage and warehousing is about storing raw and processed data, often in analytical databases. Then, data processing and transformation handles ETL or ELT pipelines, real-time analytics, and ensuring data quality. Finally, data consumption and analytics is where data is utilized for reporting, dashboards, machine learning, and application integration. Let's walk through a practical example of a multi-cloud data architecture. We can use AWS for data ingestion and raw storage, leveraging services like Kinesis for real-time streams, S3 for building a data lake, and Lambda for initial processing. Then, for data warehousing and analytics, we can move to GCP, utilizing BigQuery for petabyte-scale analytics, and Dataflow for complex transformations. Finally, Azure can be chosen for machine learning and AI, employing Azure Machine Learning for model development, deployment, and MLOps. While beneficial, multi-cloud architectures present unique challenges. One major concern is data transfer costs, especially egress fees when moving data between clouds. Interoperability and integration are also complex, requiring seamless communication between various cloud services. Operational complexity increases significantly as you manage different tools, monitoring systems, and deployments across multiple platforms. Lastly, data governance and compliance become more intricate, needing careful management of policies across diverse cloud regulations and geographical boundaries. Continuing with challenges, unified security management is crucial to maintain consistent security policies across all cloud environments. Identity and access management, or IAM, becomes complex, requiring careful synchronization of user access and roles across different platforms. Data residency and locality are critical, especially for meeting specific regulatory requirements that dictate where data must be stored. Lastly, a significant skill gap often exists, as teams need expertise across multiple diverse cloud platforms. For a complete understanding, envision a reference diagram illustrating this multi-cloud data flow. It would show data originating from various sources, ingested into AWS services like Kinesis and S3. This data then flows into GCP's BigQuery for advanced warehousing and analytics. Finally, processed data or insights are fed into Azure Machine Learning for building and deploying AI models. This visual would highlight the data paths, integration points, and security boundaries across all three cloud providers. To successfully navigate multi-cloud, several best practices are key. First, minimize data movement between clouds to reduce egress costs. Second, automate everything using infrastructure as code for consistent deployments. Third, implement centralized management tools for monitoring, security, and governance across all platforms. Fourth, diligently monitor and optimize costs regularly. Finally, define a clear strategy outlining why and how each cloud is used, ensuring alignment with business goals. Thank you for joining me on this deep dive into designing multi-cloud data architectures. I hope this session provided valuable insights into leveraging multiple cloud providers for your data needs. Remember to consider the advantages and challenges and apply the best practices we discussed. Stay curious, keep learning, And don't forget to like, share, and subscribe to Data Engineering with Subhadeep for more content. See you in the next video.